Hi-ho, new thing in this lesson, we are looking at cyclic hydrocarbons. So typically if we say something like hexane, you're going to think of that as a stick, 1, 2, 3, 4, 5, 6 carbons all strung out in a line. But if you take this last carbon and bend it around and connect it to the first one, you can make a ring shape. And we call those cyclic hydrocarbons. And their names aren't all that different from the things we've learned. They have the word cyclo in them. So when you get a ring like this, you count carbons, 1, 2, 3, 4, 5, 6. That tells you the name is going to have hex in it. And all of the bonds shown here are single bonds, so this is a hexane. The fact that it's bent into a ring means you change the name to cyclohexane. And that's it, nothing too hard there. 4 carbons is butane, so this is cyclobutane. 3 would normally be propane, so this is cyclopropane. 5 would normally be pentane, so this is cyclopentane. Then they start showing branches on them, and things get a little interestinger. Here, if this is our primary, the primary is cyclohexane. But now we also have a branch. The branch is a methyl group. So now this is methyl cyclohexane. And we should technically say where this branch is. So if you're thinking of writing 1-methyl cyclohexane, that's not a terrible idea, except remember how we leave numbers off when they're obvious? If you only have one branch, of course you would call the thing that it's attached to carbon number 1, and so they actually don't bother putting a 1 on a name like this. We just call this methyl cyclohexane. If we had a couple of branches, if we had like ethyl methyl cyclohexane, then you would have to show all the numbering because it wouldn't be automatic anymore. But for this one, it is. And last one, this has kind of interesting numbering. First of all, of course there's a cyclohex going on because of the 6 carbons in a hexagon. Cyclohex. Now, this has a double bond, so it's not a cyclohexane, it's a cyclohexene. And we're supposed to say the location of our double bonds, so typically there'd be a number in here, but if there's only one double bond, of course we're going to number the carbons on either side of it 1, 2 to keep our numbers as low as possible. That means the 1 here is obvious and they leave it out. So just cyclohexene takes care of our primary. Now, what makes this one a bit weird is we know it's going to be 1, 2, but the direction is not obvious. If we go this way, then we get 1, 2, 3, 4, 5, 6 methyl cyclohexene. Whereas if we go the other way, if we call this carbon number 1 and then go clockwise, instead of 6 we can cut it down to 3 methyl cyclohexene, and that's what we settle on. So you remember not only the location of your 1, but the direction that you go from there is undecided, and you should use that to keep the numbers you've written as low as possible. We didn't write a number here, which means we were still free to make a choice when we got to the methyl. They don't get a lot more complicated than that, but if that made sense to you, you are in good shape. All right?